Good afternoon, everyone, and welcome to today's webinar in which we'll explain the new SimScale Workbench. A pleasure to have all of you here. My name is David. I'm CEO and co-founder of SimScale. And within the next 20 to 25 minutes, I'll walk you through some of the work our product engineering teams have done over the last couple of weeks and actually months. And while this is only the first release of a significant update, not just to the workflow and automation, but also to some very basic features, we still wanted to carve out some time and really walk you through in more detail what we've been up to, why we've made certain changes, and hence this webinar today. A couple of technical notes before we go into the content. We're using GoToWebinar to stream the session today, and it offers a question and answer feature. So you can at any point in time during the session just type in questions about specific things I'm saying or specific things you're seeing. And I can see those popping up here. And during the session and also at the end, I'll try to cover them. So please make use of this, and I'll try to cover as many of them as possible. Also, this session will be recorded, so even after the session, you're going to get a recording emailed. Also, to the folks that haven't attended, they will also receive a recording of it. We're going to upload it to YouTube anyways. That being said, let's directly dive into it. And I want to start off by really sort of making a step back and sort of looking at a sort of general walkthrough through the user interface. What you can see here on the left is a small animation of the old user interface, right? It's still in production. You can still access the old user interface. I'm going to cover later how we're going to phase it out or what's the plan with it. And this is a thermal comfort analysis of an atrium, I think it's a commercial space, and a passive ventilation scenario is being analyzed here. So a very typical, very typical simulation project our customers would run. And as you can see, now we can see the CAD model, and now the simulation setup is being shown. And we can see here on the left that all the physics, all the simulation settings are being set up in this large settings panel, and I need to assign boundary conditions based on the mesh, so I can see that all boundary conditions are being defined here. And then the post-processor is loaded, and it's using a different rendering technology, server-side rendering, that we can see here. So I have a little bit of longer ping times, longer latency effects, these sorts of things. And I think most of you are familiar with that. We have a couple of new folks in the audience as well, but for most of you, this should feel familiar. And this exact workflow is now being shown on the right in parallel. Let's quickly wait until the animation starts from the beginning. So now here on the right, this is the new UI that shows the exact same workflow here. So what I can see immediately is that the CAD model is being the center of my simulation setup. So I can see I am not seeing the mesh while I'm reviewing boundary condition assignment. I load simulation results, and they're being loaded in the same tab without any ping times. So also the rendering technology has changed, and I can see that the interaction with results is as snappy, as fast, as interactive as the interaction with the pre-processing viewer. That's sort of side by side how you can see the new user interface, some fundamental changes that have been made to it. And over the next 15 to 20 minutes, I want to walk you through 8 to 10 of the most fundamental changes we've made and why, right? That existing customers get a feeling for, what can I expect here, maybe functionality I haven't seen yet, things that I can take advantage of that I do not yet take advantage of, these sorts of things, but also new users that can see sort of how we're thinking about workflow, how we're thinking about automating the simulation setup, and so forth. So I hope by the end of these 20 minutes, you have a better feeling for the new user interface and why we've made certain changes. Sort of almost as a quick agenda, this is a screenshot. In the top left, you can see the preprocessor, so the new preprocessing environment. In the lower right here, you can see the new post-processing environment. And basically, just as a table of contents, if you will, or an agenda, these are the things we'll cover, with the danger of this being a bit overwhelming, I guess. We will cover some of the fundamental user interface layout changes that we've made. So while the fundamental philosophy of the user interface hasn't changed, some sort of workflows and placements of certain widgets has. And so we're going to cover that. A couple of new viewer and scene tree changes that you can see here on the right. And then some more, I guess, subtle changes we've made to the simulation setup workflow. All of them with the goal of making the simulation setup less error prone, faster, enabling our customers to get results faster and with less hassle. Also, some of the post-processing features that have been shipped earlier than the new user interface update, I'm going to show you some of them as well in a short live demo to sort of also get a feeling for the new post-processing environment, to see what we've been up to there. But these are really sort of the 8 things we'll dive into today. And before we do that, all of this is already live in production, right? All of this, you can just go to simscale.com. Currently, the new user interface and the old user interface live in parallel on the production system. So you can access old projects still in the old workbench, and new projects are by default created in the new workbench. So in the new environment, they are to some extent compatible, but the path we're taking at the moment is that we want to gracefully phase out the old user interface. We want to make sure that all users, all customers are on board with this, and that we, don't interrupt any workflows some customers have established. We actually worked with a lot of customers, making sure that old workflows that are established also work in the new, in the updated user interface. But you never know, right? So we wanted to have this sort of sunset period, if you will, where the old user interface is still around and the new one is being phased in slowly. But yeah, make no mistake, we want to phase out the old user interface. So if you do still leverage the old user interface and you're using it on a daily basis or very often, we'd encourage you to test a new user interface right now. Work with us. Let us know if there's something you're missing. And we have this sunset period where we can make sure that the new environment covers what the old does. That being said, I suggest we'll move on, right, and also see some demos of the new functionality. This is really the first point where you can see the exact same project side by side, on the left, the old user interface, on the right, the new user interface. You can see that 2 fundamental changes we've made is, one is, let me quickly bring up the drawing tools here. Where are they? Here. So one important change was made is up here, right? Here you can see that the old user interface was being divided into 3 different contexts, right? Mesh creator, simulation designer, post-processor. That sort of split up the work in 3 contexts. And while that sort of makes sense, what we've seen time and time again is new users, also existing customers, being confused by this context switches, right? Switching. So what we wanted to do is sort of streamline this more, right? And you can see now on the right is that basically there is no context switching anymore. The 3D canvas, as well as the project content, is always in view. You have them always accessible on the left in the project tree and on the right in the viewer. So there is no fundamental switch in context anymore. The second important point is that, you can see it down here, right? We've seen that the settings panel in which most of the work during the simulation setup is happening takes up too much real estate of the user interface, right? And so we cut this down to a floating panel that sort of overlays the viewer canvas, the 3D scene, and allows, particularly in more intense 3D interactions, more space for the viewer. This is now this is again a thermal comfort analysis, so an internal CFD application, but where it oftentimes comes in handy, right? You can see, let me bring up the pointer here. You can see that this selection process here, where I'm defining the supply diffusers and the return registers of an HVAC system, you can see that this was a sort of, not the most complex selection process, but, I'm selecting sort of 27 faces, etc. And before, I needed to do that on the mesh inside a small canvas, and now I can sort of have more space, I have more room for rotating, interrogating the model to get the selection I need. Right? This was the fundamental driver here. Let me get back to here. So we talked about the single tab layout that you can see here. We talked about the floating panels. I think an important point here is that over the years in which we've built SimScale, talked with customers and observed customers, we've seen the fundamental philosophy of the user interface work, but these are sort of the improvements we wanted to make, or we saw new customers struggling with. We saw old customers, existing customers, sort of stumbling over it regularly, and so that was an important change we wanted to make. Quickly hopping over, I'll use the slides to sort of just show you why we've done certain things, but I want to make sure that you see where these changes have been applied in the user interface, and so I regularly switch over to SimScale. So this is the exact case I just showed you, right? And again, let me quickly highlight one of the boundary conditions. That's an easy one. That's a more complex one, right? So I can see here that these 18 faces have been selected here, and I have the full viewer canvas, right? You can see no tab contexts anymore. All of the simulation properties, all of the contents, assets of a simulation project live in the tree. I don't switch context. I just basically have everything that's contained in this project right available in the project tree. All of the panels, each time I interact with the project tree, basically these panels pop up here on the right, and they hover over the viewer canvas. That's the first fundamental sort of layout change, if you want. Let's go back to the slides and sorry for that, and talk about the next change that came with this update. For that, we're going to look at an external aerodynamic analysis, and I'm going to walk you through in the UI what we've done here. Let's quickly load this. All right, and so the important change here is this is a, this could be, okay, in that case, it's a Formula One car. It could be, we're seeing customers, doing wind load analysis on buildings, all sorts of other ground transportation vehicles, etc. So external aerodynamic analysis is a pretty common application we're seeing in SimScale. And so one of the changes we've made is that one of the improvements is that the original CAD part naming, as well as the colors that are encoded in the CAD part or CAD model that is being uploaded or imported into SimScale, are maintained and propagated into the SimScale simulation environment. So here, these colors that I've defined in my CAD environment do show up here again, as well as the names that I've defined here, right? And a typical situation where this comes in handy that we've observed with customers is, let's assume, I'm defining an external aero analysis sort of around this car. And what we oftentimes see customers doing is stuff like, okay, I have sort of an internal guideline that I want at the front wing and at the rear wing, a specific, element criteria or cell size that's being maintained, right? So I have a specific refinement level that I apply here. And so what I can now do is, okay, I could now obviously go down here and select the single parts of the front wing and the rear wing, etc. But I also have, and we saw customers doing that, if I have proper naming in my CAD tree here on the right, I can directly go via the scene tree and use the names that are propagated now for assignment purposes, right? So I see my front wing, I see at the rear wing the end plate left, end plate right, flap and main plane, right? And so without me interrogating the 3D model and switching, face and part selection, etc., I can directly go via the scene tree, use these new names, and use them for assignment purposes. Right? And now I could save here, and I'm done. Right? let's sort of quickly jumping back. This is what this change is about. So we have the original names, not just in the scene tree on the right, where we just saw them, right? But also they are propagated throughout the simulation setup within SimScale, enabling me to identify the names and colors or color conventions that I typically use in the CAD system upstream. All right, that's sort of the second thing I wanted to cover. And yeah, colors, we talked about them as well, right? It's just fundamentally enabling the user to better find in SimScale what I have defined already in the CAD environment, right? So making this sort of the downstream workflow easier for the user. All right, the third little feature that I quickly wanted to cover is, let's quickly also hop over to a SimScale project, is the capability to look inside specific models. So basically a translucent view. And a primary application where we see this happen regularly is, this is, again, an internal environment, right? In the old workflow would have been, okay, I sort of select faces, I hide them, etc., right? And then sort of I interrogate the model like this. Regularly, what we've seen is sort of that just something like this comes in handy, right? So with one view, I have the entire context of my CAD model. I see what I've defined. Since the, again, on the right, you can see names are persisted, colors are persisted, and with the translucent view, I get an immediate overview to sort of where is what. And I can use this translucent view, we're going to see that later, also during my assignment operations, right? When I'm defining boundary conditions, when I'm assigning, I don't know, result control items and the likes, I can use the translucent view as well to make sure, or to simply increase my my confidence that I'm assigning stuff on the right position. All right, let's quickly close that again. We talked about this, right? The translucent view. Yeah, and it's all of the viewer interactions are now accessible via a more sort of a smaller viewer menu at the top of the viewer that hovers the viewer. And so the translucent view is next to the other view modes such as, you know, show only edges, show only surfaces, etc. You can find it at the top here. All right. So much more or less just general interface changes, right? Making interrogating a CAD model easier. Now a bit more sort of subtle things you might have not seen yet. And for showing this, we're going to hop over to a contaminant analysis. So that's also a simulation we see happening often in SimScale. So that's a parking garage, right? The flow volume of a parking garage. Let's take advantage of the new view. So I can see pretty simple, right? I have the room defined here, and this simulation is already carried out, right? I can see it is an incompressible flow analysis. I'm using the K omega SST turbulence model. It's a steady state analysis, and I have one passive species as a passive scalar defined, right? And again, we could now go in here and sort of look at, you know, results. Let me see if I did some post-processing already here. There we go, right? This is a this is now a carbon. I think it's a carbon monoxide analysis. So this is the level of carbon monoxide, and you know, being basically being the cars generate this carbon monoxide in here, and I'm looking at how does this one is the carbon monoxide being distributed during normal operations, right? And the application of this would be how to place jet fans best in this parking lot. Now, this is not what I wanted to show you. Now, the one of the significant improvements is that if I'm, for whatever reason, saying, okay, I do want to switch my analysis, say, from a K omega SST model to a K epsilon model, you know, to test another turbulence model, or because I've just seen, okay, it might be the better choice. In the old workbench, if I would have done that, all settings of my simulation setup would basically snap back, right? Because it would have been treated as a completely new simulation. Now with the new user interface, I can just do that, and nothing changes, right? So literally no assignment here on the left has changed. I can see that new physical quantities are being propagated inside the simulation tree, so I might need to revisit them, right? But everything else, so say, velocity inlet or boundary conditions assignment, I can see all of this is kept, right? The same goes for, say, I looked at this in a steady state analysis, but now after having done that, I want to run that actually in a transient analysis, which actually is regularly the case depending on the building code such analysis is being carried out. But I can switch this to transient, and again, you can see on the left, the simulation tree stays more or less the same, right? Obviously, I can now find new simulation sort of options down here, but overall, I do not lose any of the work I put into the steady state simulation setup. You can just carry it over into the transient analysis setup. Same goes for, honestly, I'm lacking the creativity to what I would want to do with more passive species, but I could just go in here and say, hey, I want to look at 3 different passive species, and again, no disruption to the simulation setup. All of the values are being carried over to my new simulation. It might look like a subtle feature, but we have many customers that said, I'm losing just a lot of time in these simulation setup changes, so we made this simply more robust for switching these detailed setup changes. All right, back to the presentation. We talked about it, right? So faster changes are being supported when I make global changes or changes to the global settings. And another good one, also probably a more subtle one, but we're gonna dig into that one as well with a new example. Let me directly show that to you again with an actual application here. So this is an atrium of a I think it's a commercial building, and let's quickly change the rendering mode, and I have a bunch of rooms in here, and what I'm looking at is a scenario where these 4 doors here, let's simply look at the boundary condition assignment, right? So those 4 doors are open, and I'm having some wind coming in here, and I'm looking at a passive ventilation scenario, how well I can ventilate this atrium using just passive ventilation, right, without having a mechanical HVAC system turned on. But again, it's not about the physics here, it's about the workflow. And so I might go in here and, I might have some first simulation results. Let's take a quick look. Here, again, this is a velocity plot, right? So I can see, again, that's what I would expect, right? I'm looking at velocity magnitude, and I can sort of scroll through here and see, all right, fair enough, probably a bit drafty there, and for whatever reason, I could come to the conclusion that I'm saying, okay, because let me quickly show the mesh. So I can see that this was generated with a hex mesh, right, or hex dominant mesh, right, and so I might come to the conclusion, okay, I want to run that either, with a finer mesh, or what I quickly want to demo simply with a different mesh generation method, right? And let's quickly hop back to the simulation setup, and here I can see this was the mesh I've generated for this analysis, right? And the beauty now of the new simulation environment, of the new user interface, is that I can just swap the mesh as soon as it's derived from the same CAD model without any reassignment. And so we'll quickly do that live. So I'll quickly see here, okay, I have 3 different meshes, right? So I'll say, okay, I want a TED mesh actually now to use it, right? And again, please note the simulation tree on the left. Nothing has changed, right? All settings are being applied simply to the new mesh, right? And you can see here, clearly this is a TED mesh, right? And I hop back to the boundary condition assignment, and it's maintained, right? I can see none of this has changed because the simulation setup is being done directly in the CAD model, and the mesh, the underlying mesh that's being used for the analysis, can simply be swapped out, right? And again, I've quickly done that before, so just to show you, so down here, I made a copy of the simulation setup, did exactly what I just showed you. I swapped the mesh below, and again, this is almost the same result here, right? So I'm looking at a very similar result. And just to drive that point home, we'll quickly select the cutting plane and show the element mesh, and there we go, right? We can see that's clearly a tat mesh. It's a different one than before. Again, I mean, in this scenario, I showed you how you could, and again, you can see also the layers, I suppose. Yeah. And this was just to show, okay, you can use a different mesh. I think a common use case would be that you run the same analysis with differently resolved mesh, right? A mesh independent study, and this sort of easy switching or easy swapping of meshes sort of just makes it so much faster to run these grid independent studies and less error prone. Last point here, I think also the assignment process, since I am used to my CAD model, right? I've designed this, I know it, I see the edges, etc. The assignment process on the CAD model also came a lot of feedback from customers. It's much easier, much clearer, right, than the assignment process on the mesh that the previous user interface required. All right, that being said, quickly hopping back to the presentation. So we talked about it. You can see it here. That's exactly what I just showed, right? The CAD serves as the primary environment on which I define physics for a simulation. And then the meshes, the underlying meshes that are being used for the actual analysis can simply be swapped out, right? Without any additional work generated for the user. Let me quickly drive one point home, because important for us was that we do not lose flexibility in terms of mesh generation, right? We didn't strip away any of the flexibility you had in terms of generating meshes. So you have the same powerful algorithms, you have the same powerful environment, you can generate multiple meshes for a CAD environment. The beauty is just that the assignment is directly done in the CAD model, and so you can just swap them out, right? So no meshing functionality has been reduced. All right. Last but not least, a couple of, the postprocessor was shipped a few weeks earlier, but you can see that the same sort of philosophy we've been using in the pre-processing environment also extends to the post-processing environment as well. So I want to at least quickly show you 2 to 3 new features in the post-processing environment as well. So let me quickly open this up. And we don't have time to sort of extensively go over all of this, but just, a general overview for you to get a feeling for what's new in post-processing. First and foremost, it might not come across the stream of GoToWebinar directly, but the post-processor now also uses client-side rendering. So this rendering is done on my local GPU, right? So there's no ping times. I have direct feedback to my mouse interaction. I have a much more direct feeling for how I rotate and zoom and pan the model, right? So this is almost in real time. And the same extends to most of the interactions with the result as well. So this is now, a simple FEA analysis of some chassis. And what I want to do here is just show you how much more interactive the new postprocessor is. And so to show that, this is a new ISO volume plot. So you can see I'm looking at the von Mises stress of this linear stress analysis. And what I want to highlight is I want to get a feeling for where are my high stress areas, right? And as you can see, I'm sort of sliding through this ISO volume plot. Instead of I'm changing the lower threshold, and I can see the 3D view updating in real time, right? I can zoom in and sort of get a feeling for here's a high stress area, right? And I can narrow that down and see, okay, where I'm having my welding done here, etc. And I think the important piece here is not necessarily the physics behind the simulation, but really the level of interactivity I'm getting with this new post-processor environment. This is I think we're looking at a couple of 100,000 nodes. So this is not the largest model, right? So as the model gets larger, the update becomes less real time, but still the philosophy is sort of you make a change, you immediately see the effect it has on the visualization. Let me remove this ISO volume and toggle back the full view here. And so another feature that was often requested was, let me quickly zoom that a bit up. Okay, let's assume. I mean, yeah, while we're at it, I mean, I can, change color scales here, so I can make it less. I want to have less numerical levels, right? Almost sort of a discrete plot, right? I can make it continuous. You can see like all interaction I'm having here on the left is immediately reflected in the postprocessor and in the 3D view. Okay, and then one important feature that was also requested was the ability to just conveniently probe inside the results, right? So I can just go in here and say, okay, what are we looking at in terms of stress back here, right? And I can see that on this element, I get the exact von Mises stress, right? So I'm looking at what 20 megapascals here. And I can do that and sort of see, okay, what am I looking at here, right? And what I'm looking at here and over here, etc. So without the necessity to define such a result control plot before the simulation setup, I can directly probe inside the simulation environment in here, right? Inside the post-processing environment, and see that in real time updated, which was also something a lot of customers asked for. All right, you can, there's many, I could go on. I really encourage you to sort of, play around with this one. Let's quickly, like a last one, swap this over to being the same extents to sort of the way how I can sort of interact with cutting planes, right? This is now an FEA analysis, but in CFD, this comes in also super handy when I'm exploring, a plot through a flow field. Again, all of this interactive, all of this sort of everything you interact here on the left, you can see immediately updated on the right. Before we leave this screen, everything you define in here, right? Everything you define inside the post-processing environment is automatically persisted for when you come back the next time, right? In the past, you needed to consciously save a certain, visualization you have generated in the post-processing environment. From now on, it's automatically persisted and being loaded the next time you visit back. All right. And a quick wrap-up of this as well. Fundamentally, the entire menu on the left gives you many more plot types, many more visualization options that you can use. We're just getting started, right? It comes with most of the ones you're used to from the old post-processing environment, and on a monthly basis, new plots, new functionality will be added to this post-processing environment, and all of that based on this new technology stack that allows for true interactive rendering, right? Interactive interrogation of simulation results, with this philosophy of every change you make in the settings panel, you can see immediately being updated in the 3D view. All right, let me quickly hop back to the overview. So we've covered the one-tab layout and the floating panels, right? The general sort of update to the user interface language. We've covered the translucent view here on the right, that you've seen that's accessible and comes in handy specifically for internal flow simulations. We've seen how original part names and original colors of the CAD model simplify the simulation setup because you're seeing what you've seen in your CAD environment, right? Whatever you defined in your CAD environment is extended into SimScale. More subtle changes such as the simulation setup improvements where I can make global settings changes, and everything, not everything, but everything that makes sense for the new settings is maintained, right? So I don't lose any of the work I've put into a simulation setup just because I'm changing the turbulence model. We've seen that as well, right? CAD assignments, you've seen that the CAD model serves as the environment or serves as where I'm defining physics, and the mesh is being just treated as something I can swap out easily in the background. And here in the lower right, we've covered or we've seen some of the much faster interrogation of a post-processing results, as well as a couple of new of the plot types that we've introduced. All right, hopping forward. So the big question sort of that I want to conclude the session with is sort of, you might now ask yourself, or you should ask yourself, right? Why should I care, right? What's in it for me? I hope some of these changes, some of these enhancements, you can already see a use case for your own work, right? Most of them are really driven by customers approaching us. Hey, I'm losing time there. Hey, it would be great to have this. A lot of these changes have been identified while shadowing customers when they interact with SimScale, when they set up the simulations. And so we really try to cater for this, right? And the guiding principles have always been trying to enable the user to get results faster, right? Because ultimately simulation is not an end to itself, right? Simulation results are just there to make a better design decision, right? So enable the customer to get results faster. And it's primarily done by, you've seen that the new postprocessor loads much faster, right? You can interrogate the results much faster. You've seen that while I'm running a mesh, I can already start setting up the entire simulation setup, right? I do not need to wait until the mesh is finished. I can get this done right away, right? And that way I can parallelize the work I need to put in to get these results. Last but not least, you've seen some of the first steps towards more automation within SimScale, such as I'm changing the turbulence model. All my prior settings are being maintained. I'm changing from steady state to transient. Everything, all settings that make sense in the new simulation setup are being maintained. I'm adding passive scalars, yada, 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 right? All of these things, all of these changes do not need to be redone by the user. Same when switching the mesh. I do not need to reassign anything, right? So more automation in the general workflow. Another thing that we spend time with is making sure, or making SimScale less error prone, right? Making sure that the user ideally gets from A to Z, Z being an accurate simulation result without any detours, right? Being able to swap out a mesh without needing to reassign a complex assignment workflow simply reduces the risk of introducing unnecessary errors, right? Easily being able to swap out meshes will allow our customers to run mesh-independent studies much faster, right? And as a result, being able to generate more accurate results faster. Most of that, I hope I could visualize during these demos, during these little sort of workflow demos. The one thing that might not have been so obvious is on the, if you will, behind the curtains, right, on the back end of SimScale, this new interface is driven by also a new stack on the back end. So we've exchanged fundamental technology stacks within SimScale with the primary reason of allowing us to ship more functionality faster, right? So this, what I've just demoed over the last 20 minutes is really just the first chunk of features, improvements that was enabled by this new stack, right? And I would recommend you watch our website and watch out for additional emails in your inbox over the next weeks, because this is just the first step towards making SimScale easy to use, making it faster to use, more automatic, and last but not least, adding physics functionality, adding CAD functionality, adding mesh generation functionality more rapidly, right? And that's something I put here in progress. That's something, that's not sort of which we will start, or something that the team is putting in on a daily basis, is hard at work to ship that. I hope I sort of, could wrap this up and make this worthwhile to you and give you a feeling for the new user interface. If there's, and I just realized I went significantly over time, so apologies for that. So we won't have much time for questions. I'll look through it. And if there's any question that is unanswered today, you can either directly reach out to your customer success engineer at SimScale, or support at simscale.com, or engage in the forum, or reach out directly to me. We're here to help. With that, I'm concluding the session for today. Covering some questions now, but concluding the official part here. Thanks a lot for spending time with us. All right, let me quickly bring up the questions here. There's one coming in from, let me see. Oh yeah. One question from someone in the audience is, let me quickly go back to the slides here, is whether or not names can be changed or edited inside SimScale of the CAD model. And I think this might be a question that's relevant to more folks, because I'm seeing a lot of very special questions here. Currently they cannot, right? So whatever name is being found in the CAD model at upload time will be displayed within the SimScale UI. So this means you cannot change individual part names within SimScale. What you can obviously do is the ability to group certain parts, faces of your model to sets is still there, right? And these sets can be named, etc. So that's being, no change there compared to the old user interface. But as of now, you can't change them right now. It is a feature request, so that is something that more people have asked for. But as of now, it's right now not within the user interface. Let me see. A lot of very specific questions to specific simulations. So here's another general one. Are we able to render the post-processing, or I'll translate a little bit, to render the results during post-processing still on the server side? Basically a two-part question. Let me quickly swap forward. So currently also the old post-processing environment is still being kept around, right? So the old post-processing environment is still accessible on the production system. And you can visualize all results in the old and in the new post-processor. But this is also just as a sunset period. So the old post-processing environment is planned to be phased out. So if you are relying on some functionality, on some, something you see isn't working in the new post-processing environment but is in the old one, I'd encourage you to reach out to us, right? We're currently in the phase, and obviously we're testing a lot, making sure that all results can be also post-processed in a new environment. But if there's a specific use case you see not working in the new post-processing environment, please do reach out to us, and we want to make sure that this works as well. The second part to the answer is, right now it's really only client-side rendering, right? But there is already sort of on the horizon sort of thoughts or experiments around being able to also do that server-side, right? So I think what we're trying to do is we're seeing customers simulating larger and larger models, right? And I do see the option that moving forward will actually extend the current client-side rendering within this framework also to a server-side rendering to leverage GPUs based in the cloud. That's sort of that's certainly an option, but right now it is not. In the new post-processing environment, it's definitely always client-side rendering. All right. I hope that answered the question. Let me quickly see if there are more, because we're really running out of time here. Let me see if there are more general questions. A lot of them are very, very specific, and I would really encourage you to reach out to your customer success owner or directly to me. I'll address some of them by email. If there are no more general questions at this point in time, I would wrap it up right now. Again, we'll make sure we'll get the specific questions answered offline afterwards. And so with that, then I would conclude also the Q&A afterwards. Again, thank you so much for spending time with us today. And a last important note here, we're really looking forward to feedback, thoughts, improvements, suggestions around SimScale in general, and particularly now about these new workflows, about the new user interface, right? So if there's, if you have some thoughts, it can be positive, it can be negative, it can be something you're missing, I would really encourage you to send all of your suggestions to support@simscale.com or the forum or via support ticket. We funnel all of these channels in one system here on our end, and that allows us to prioritize feature requests, opinions of customers. So I would really encourage you to, if you have any thoughts, please do share them with us. We're looking forward to that. All right, again, thank you so much. Have a great day, and bye-bye.